our conference with the next guest speaker, Professor Douglas Hargreaves. Professor Doug Hargreaves is an Emeritus Professor in Mechanical Engineering at Queensland University of Technology. He has spent his professional life in a mixture of academic and industry practice. He was National President of the peak professional body for engineers, the Engineers Australia, and Head of School of Engineering System at Queensland University. He returned to teaching engineering students a unit called Engineering and Sustainability, which effectively taught engineering graduates what to do in the real world. He has published multiple papers on engineering education, tribology, and leadership. He also co-authored a leadership book called Values-Driven Leadership and chapters in several other books. He was awarded a member of the Order of Australia in the 2014 Queen's Birthday Honour List for a significant contribution to the community and engineering education. More recently, he is the Executive Officer for the Australian Council of Engineering Deans, chaired the Technical Committee for the World Engineering Convention, WEC 2019, held in Melbourne. He also represents Engineer Australia, the EA, on the Federated Engineering Institutions of the Asia Pacific and chairs EA International Advisory Board. So everyone, please welcome Professor Douglas Hargreaves. Hello, Professor Hargreaves. We're so honored to have you here today. And before we start, how are you feeling?
I'm feeling okay. A little nervous until I get these slides up onto the screen, but never mind. Hopefully we can get that and then we'll be fine.
Yes.
But I'm okay. Thank you very much for asking.
Yes. We're also very excited to see you. And I know that all of our audience, including your old colleagues, or your old friend, are really eager to your sharing. So whenever you're ready with your slide, the stage is yours. Thank you.
Okay, let me just see if I can do this. Let me share the screen. I need to go to here. What's happened here? That's gone. I shouldn't have that. There we are. Can you see that? Can you see that on your screen? I can't hear anybody, but I can hear an echo of my own voice.
I cannot see anything. I cannot see your PowerPoint.
It's on my screen. The slide is on my screen. What do I need to do to make so that you can see it?
So have you shared your screen yet?
I did, yes.
Oh. So normally we just share the screen and then...
Yes, I realize that.
I think you may share your computer. That's why we have like the echo sounds.
Maybe I need to start again, do I?
Just share the window or a tab. Don't share everything.
Hang on, I'm going all over the place here. End show. So if I go back to here. Can you see me now? I'm on.
I just see you, but I don't see your screen.
So if I now go to share screen, yeah? Share screen.
Can you see the share screen button, green button on the bottom of the screen?
I've got my slides up on the screen. What do I need to do now? It's so but you can't see them.
Yes, we can.
Maybe I'm sorry to do this, but I mean, you've got the copy of my slides as well, have you not?
We have your slides.
Can you put your slides up on the screen and I will just talk to them?
Sure, we can.
So I will get out of this. Oh. Not sure.
Can you see the?
Ah, there we go. So I can see the screen. So you've put that up on from your end, is that correct?
Yeah, we put it on our slides.
Okay, let's go with that. And I apologize because I couldn't get them up for us. Okay, so I just want to introduce a little bit about what I'm going to talk about today. If we can just start here, I think there are lots and lots of information around the world which is saying this is the characteristics or these are what the world is needing of not just engineering graduates, but also all graduates. And so I'm going to focus very much on engineering, obviously, because that's where my background is. So there's lots of information around, and it says this is what has to happen or this is what should be the case. My follow on from that is, well, who's going to do it? And how are they going to do it? And therefore, therein lies the title of this talk. That is, it's about the engineering educators or the lecturers. They are the ones who are actually going to make all this happen. And so therefore, they become the change agents from what we have now to what we would like to have as the knowledge, skills and attributes of our students going forward or graduates going forward. So if we can move to the next slide, please. Yep. So this is out of the World Engineering Forum, and it says that these are the sorts of characteristics or competencies that an engineering graduate needs by 2025. Now, 2025 is almost here. So we're not going to reach it, even though there are lots of really good educational programs around in the world for engineers, and we're certainly moving towards that in the end, moving towards that. So the things like analytical thinking and complex problem solving and creativity and leadership and resilience are all. You're going to hear me say those words several times in the next little while. So that's what the World Engineering Forum has come up and said, these are the skills which are required for not just engineers, but for everybody. So we'll go to the next one, please. I might also say at this stage that a lot of these, the first part of this presentation is going to just say all of what is sort of required, and then I'll get into some examples and a specific example in terms of what I think or how it could actually happen. So here's another report which came out of the Australian Council of Engineering Deans. They've undertaken for the last 3 years what we're calling Engineering 2035 project, where the real question was, what are the skills, knowledge and attributes required of an engineering graduate in 2035? On the left-hand side, you can see there's a list of what happens now. That means very technical information is required, problem solving, problem definition, design, etc. That's what's going on now. Future, more complexity, more multidisciplinarity, more cross-functionality, a greater public accountability, social engagement, sustainability considerations. So that's what this report is saying is required for the very near future. And the future, by the way, I think is now, or even tomorrow or next week. We don't have to wait for 2 or 3, 4, 5, 6 years. It's now. So all these things should be happening as we speak. So the next slide. This one comes straight from UNESCO's report on what a global citizenship values are. And again, you can see here values such as diversity, equitable treatment of others, the ability to handle ambiguity and unfamiliarity, critical thinking, debating, moral reasoning, intercultural communication skills, and the list goes on. But they're not all totally unfamiliar for us, because we hear that in lots of other places as well. So even though this list is for the global citizen, that also includes engineers. Next slide, please. The next slide is just for those who wish to have a look at the different reports and so forth that UNESCO has written. And that's the list. I'm not going to go to those lists, obviously, but if we can move to the next slide, would be really good, please. So now I just want to say a little bit about this here, in the sense that engineers are really good at the reductionist capability. Reductionist means we pull it apart and we design and amend and repair and change little bits of the whole system. And then we put it all back together. So reduction, we pull it apart, we design the bits, and then we put it back together. And what has happened over the many years, engineering has done, so the whole profession of engineering has come into lots of disciplines. And that's what we've done in discipline. We've pulled the disciplines apart and said, okay, well, we need more than just civil, mechanical, electrical, chemical, whatever, but we need all these other ones now. So, and a typical example might be mechatronics, where we have a combination of mechanical and electronics. And we have a whole lot of other disciplines of engineering, which are now available for students to choose and to study. So what this means is that there is, now that we are almost turning the circle, if you like, because people are saying, reports are saying, we need to be more multidisciplinary. We need to work together. And so it's almost putting all these things back together. So what it means to do engineering is changing. And I'll say that again, it is changing. And engineering disciplines are becoming more contested. Skills like, again, problem solving, customer empathy. Now, who would have ever thought that customer empathy would be important for engineers? I mean, the stereotypical engineer is the one who does the calculations and drawings, et cetera, and the project management. But customer empathy? Good question. Creativity, collaboration, et cetera, also very highly valued for the engineer of the future. Next slide, please. I think we skipped one, did we? Oh, no. It's okay, back. Can we, that's the one, yes. So this comes from James Trevelyan, who is a researcher in engineering, the practice of engineering. So he's saying things like, this is to understand engineering, we need to understand human capabilities and social behaviour, as well as the law of physics. We tend to, over the many years, focus on the laws of physics and the applications thereof. But now, to understand human capabilities, to understand social behaviour, that's going a little bit far, a lot of people would think, in terms of skills required by graduate engineers. And James also says, in engineering, social and technical are intertwined, inseparable realities of practice. And for those of us who have been in practice as well, we know that that is true. So the real challenge, therefore, for the educator is how do we teach the laws of physics, as well as somehow or other embodying human capabilities and the social aspects of engineering as well. And the last comment that James puts up on this slide here is that collaboration or working with other people is the most important aspect of all engineering practice. So we can have all of the hard, if you like, engineering, the technical stuff, but collaboration and working with others is most important, because without working with others, nothing is really going to happen. So sustainability and ethical things, really, really important. Okay, next one. So universities, this comes from Jeff Connolly, these comments. He's the CEO of Siemens in Australia. And Siemens, as many of you will be aware, is a huge international company. And Jeff says, universities need to continue providing fundamental discipline knowledge. That's what we do now. And along with an environment for students to be collaborative, creative, and flexible. The role of a future university is to create change makers through new pedagogical approaches led by technology. I don't know that anybody would disagree with most of all of this, but as I said right at the beginning, how and who is going to do this, and which I'll talk to you a little bit more very soon. So that's not just, so a lot of the other stuff has come from sort of the academic world. Now we have the industry saying same or similar stuff. So this next slide is coming as well from some comments which were made as part of the Australian Council of Engineering Dean project. We actually interviewed a whole number of thought leaders, not just engineers, by the way, but thought leaders in the society. And so this is two comments which has been made. And one of them, the first one, this is, if engineering education is going to be relevant in the future, and let's hope that it will be, because certainly the UN Sustainability Development Goals won't be reached without engineering or technology at all. So if it's going to be relevant, it perhaps needs to look at itself and take on board the way that it deals with, and here we go again with some of these words, multidisciplinarity, that its role models the type of attitudinal engagement that we need in the broader societal and environmental issues. So engineering now cannot be just simply the technical side. It now needs to embody things like environmental issues and other societal issues. I won't go through the other comments, but it's there for you to have a look at. I'm assuming that anybody can get these slides. I'm happy to share these slides around. If the organisers just can do that, that would be fine, if you so desire to have them. Next one, please. So what does this mean for universities? Because universities are the ones who actually make this happen or not. So the sorts of things that we now need to do from a university perspective is to include such things as multidisciplinary engagement, systems engineering, human dimensions and societal impacts of engineering. That's in a curriculum now, or should be in a curriculum now somehow. Collaboration at the interfaces between engineering and other professional expertise. To some extent that happens now, but it's got to have, I think it needs to be more focused now, and must be external engagement with, and practice with industry and the community. So there's got to be a lot of things happening. Engineering providers, I'm saying that's sort of at the university level. So they're going to have to introduce these sorts of characteristics into their curriculum. And that is not going to be easy at all. So we'll go to the next slide, please. And so universities can't do it without the educators or the lecturers. So this is really interesting stuff as well. It's how you communicate engineering. I think it needs a new breed of educators. Note that, a new breed of educators who are actually great communicators. Yet they understand the power of storytelling, but it's more about the content of the story. And so, which is the engaging, and that will have the impact. So the engineering educator, rather than pretty much sort of standing out the front of a class of 50 or 100 or 200 or 400, now has to be, or should be, a really good communicator and storyteller, as well as a few other things which are noticed down below. So for that to happen, educators, maybe they should be more practice oriented. That means they've got more practice in their experience. They are better to engage and inspire students. That means that they are able to take risks, if you like, by challenging students and students to give answers. And so even though the lecturer, educator may not have all the answers, they need to be prepared to face those sort of situations, which hasn't always been the case, as we all know. Okay, let's move on. So now I'm going to stop at this point to say, if we accept all of that stuff, and the whole world seems to be saying that's what we need to do, that's what we want in our graduates these days and in the future. And I say these days, as I said before, that's now, and the future is tomorrow or even today. The very first slide that I showed you said, here are the top 10 skills needed for 2025. That's only a couple of years away. And so we really need to get onto this and do it really quickly. So what I'm saying is, I guess the guts of all this whole talk is about, if we accept all of those things, and I don't think we have a choice, how do we make it happen? How do we include it in the educational curriculum? How do we ensure that the educators have the needed skill set? And that's another big issue. It's easy to say, well, the educators need to do this and this and this, but they also need to be trained in order to be able to do those things. Okay, next one, please. Now, I've done just a few examples here of how we might be able to do this. That is, embed some of those characteristics or requirements of learning outcomes, of intended outcomes of our graduates. Here are a few examples. These are not the only examples, but they are a few which are being used around the world as we speak. So collaborative learning spaces, and I will talk more about that as we go on. And that'll be the example which I focus on and talk a lot more about. Flipped classrooms, I'm sure that you've heard that term lots of times. Just be aware that there are many different definitions of flipped classrooms. Work integrated learning. So as a student needs to have involvement in real work and real practice. And so how does that all happen? Project-based education, problem-based education, directed self-learning. Notice that it's not self-directed learning, it's directed self-learning. And I'll use that example a little bit later on. So what I'm saying to you is, here are a few techniques that can be used to help embody, to integrate those characteristics into the engineering curriculum. I say that by integrating and embodying inside, because we can't keep adding to the engineering course. It's already 4 years long. To say we want to add another 1 or 2 years to the education program is just not a real question. So my view is that it needs to be embedded into the existing curriculum. Okay, next one. Now this is a case study, and Gary Chadwick, who is sitting there, I know will know this very well. This is an example of what I did, or what we did, I should say, at Queensland University of Technology. And we started this in the early 2000s. And what I'm going to talk to you about is happened in the sort of 2011, 12, 13 type era. So it's already, what I'm about to tell you is already about 10 years old. So what you see here on this diagram is a plan view of actually 2 rooms. And each of those little bundles of rectangles, they represent chairs. So we have 6 students on each of those little bundles. So in any one group, you've got 10 or groups of students around that room, and there's 2 rooms there. So you can see you can put, I don't know, maybe 60, 70 students into that room. And so this is a room which has been very specifically designed at the university for the process which I'm about to talk to you about in these collaborative learning spaces. So the next slide, please. This is just some pictures of students around the table and working together. And that's pretty straightforward to see. I want to show you there's some mixture. It's really important that we have a diversity of students around the table in terms of age, because some students are a little bit old, they come as mature students, in terms of gender, and you'll see males and females, and also in terms of what type of engineering the student actually set out to do. These are first year students, and there's 1,100 of them in the class, and they come from all of the various disciplines of engineering that QUT offer. So you can see just a few pictures there of them, and I want to talk to you now about a lot more details about how that all worked. And so if we put the next slide there, please. Okay, I said there were about 1,100 first year engineering students at QUT. And I had the privilege and huge challenge, of taking these students through that subject which was known as, or the unit known as Engineering and Sustainability. I might say that no lecturer wanted to take it and no student liked it. So that for me was a huge challenge, and so I took it on. We couldn't have 1,100 students around the table like you saw in that previous slide. So the class side was broken up into about 50 or thereabouts. And then that 50 was broken up into individual groups of 6. And that's what you saw around the table. Pardon me. I just want to say a few things. Every one of those, I'll call them tables, but that means a table of 6 students, had access to the internet. So they had obviously a computer and a monitor there, which you saw previously. And that's really important. Excuse me. So the students did a project for the whole semester called the Engineers Without Border project, which in itself is a really, really good project for students to get an awareness of the breadth of engineering, and not just engineering, but of their particular civil or mechanical or electrical or biomedical, whatever, engineering. And so part of it, a good part of it was to actually get them to think critically in a systems approach. Communication was really important, and how we did that, I'll talk to you in a second or two. So it was all about the Engineers Without Border project, and that project might well have been how to build some sort of building, some sort of structure in a remote place in the jungle, for example. And so students couldn't actually just say, I'm going to build that out of steel and whatever. So then say, how do you get that there? And how do you get the concrete there, et cetera, et cetera. So that EWB project was really, really good in a sense of making students think outside of their so-called stereotypical box of, we'll make this out of timber, or where are you going to get the timber from? Maybe we'll make it out of, we got a good idea. We'll make it out of bamboo. Great. That's really good. Bamboo is a really good structural material. And so my next question is, where you get the bamboo from? Well, there's plenty of bamboo growing around the place there. I said, yeah, well, if you cut that down, you just destroyed the habitat of the orangutans. Now what are you going to do? So, excuse me. So by doing that and by questioning them, not meant to be blocking their ideas, but to say, you've got to think more broadly, much more system oriented. So you can't just say, I'm going to build it out of this and be done with it. And there's also about an issue about how to get it there, the transporting of it to the site, etc. So I just wanted that project, I think, was really, really good. And every year, the Engineers Without Borders have different projects around the world, really good ones. There were no lectures. I didn't have any formal lectures. But what we did have was I'll call mini lectures. And a mini lecture might have been 5 or 10 or maybe 15 minutes long, that's all. And let me tell you an example. If we wanted to talk to the students about project management, and every engineering student will one day, in some way or other, be a project manager. The project might be very small or it might be very big, but whatever, they will have to know something about project management. Now, I could have given them a 2-hour lecture on a Gantt chart, project management, etc. But no, I didn't do that. What I did was I told them the importance about project management and why engineers need to know about it. And then I would go to each of those tables with a bundle of post-it notes and say to that table, I want you to now think about how you would plant a tree in the back garden. And they look at you and say, I thought we were doing engineering. And I said, yes, you are. And when we go through this process, I will show you how engineering is involved in it all. So after a while, they'll actually get an idea. And there's 6 of them or 7 of them are working around it. And the idea was to write on every post-it note a task, like decide what tree we're going to plant, where we're going to plant it, what tools do we need to dig the hole? Do we need fertilizer? Do we need water? What do we need? So all of those tasks were put down one at a time on a post-it note. The next question was, I want you to arrange those post-it notes in a sequence that you would actually do the job. And that's fairly straightforward. And then I would say, now you've got 3 people, not 1. How are you going to rearrange all your post-it notes now to actually still plant your tree? And in the end, what they've got is a Gantt chart, something which is really important in any project management. So what I'm saying is that I can call that, if you like, directed self-learning. I directed what they had to do, and they actually put it all together and learned themselves. As another example to that, sustainability, really important for all of us these days, not just engineering. So there are lots of definitions of sustainability, and a lot of us, just that word rolls off our tongues without really knowing what it is or what's it about. So my question to the groups of 6 around the table were, I want you to go onto the internet and find some definitions of what sustainability is. And then all of a sudden they realize there are lots and lots. And so I come back and say, okay, now as a little group, I want you to write your definition of sustainability. I mean, I had other things to do as well, but I'm just asking this as an example of how to get the students to do, to learn by learning themselves or teaching themselves. One of the examples, I also got them to look up things like on biomimicry. What in engineering is a copy of stuff which is happening in the natural world, if you like. And some examples were, why is the front of the bullet train so shaped? What? And they will soon find out that it's built on the kingfisher diving into the water, a bird diving into the water to catch fish. Or where did the idea of Velcro, in material, where did that come from? and they look up these things, and so they're learning. I'm just asking the questions. They go through and do all of those things. And just as a little aside, it's not that long ago that aeroplane wings, real aeroplane wings, were straight out. Now they all have this little winglet on the end, little bit which turns up. Where did that come from? That came from looking at an eagle flying. And we won't go any further onto that. But all I'm saying is using those things to help the students learn for themselves and with their peers in a group of 6 or 7. Communication is a really interesting one. From, when I was a student, which is, a couple of 100 years ago, almost, some people would say, there was no such, no emphasis at all on communication, none at all. Now there has been over the years a lot more emphasis put on communication. But the thing which is frustrating is that industry still says students need to be better communicators. Sorry, engineering graduates need to be better communicators. So what I would do with these groups was that in every class that I had, every time, I would get at least one student to stand up for 1 or 2 minutes most and tell us a little bit about what that group has just been doing. For example, I would ask one person from the table to stand up and say to the rest of the room of 50 or 60 students, what's our definition of sustainability? And nobody was to question it or whatever. The main thing was to get individuals to stand up and say something in front of the rest of the class. This was not assessed, so therefore it was safe in that sense for the students. They weren't going to lose marks, they weren't going to get marks either, but it was about scaffolding over the term of the semester their communication skills. And there were some, there was one example which I'll never forget. In week 1, this guy, his name was Brian, says, I can't communicate, I can't stand up, I can't talk at all. And look, my hands go all wet. And they were. But nevertheless, he did stand up and he did say a few words. By the end of the semester, he produced one of the best presentations of all of the 1100. Because, in effect, we had provided a safe place for him to, if you like, practice or scaffold his communication skills. Simple as that. Well, it's not always simple. By the way, none of these things happen really easily, and there's always quite a lot of pushback from the students. But never mind. In the end, they know and they appreciate very, very much what it's all about and why we took that approach. So I said to you there was 1,100 students in the whole class, and there was 50 or so in each room. So what I had was obviously a long number of tutors or others who would take the classes because I couldn't take every one of them. But what I spent an enormous amount of time on was actually training the tutors or training the other lecturers to say, this is what I want to do, and providing, if you like, the notes of what we were going to be doing for that particular week. I mean, I'll just go back to the little mini lectures. That this week we're going to be talking about sustainability. This week we're going to be talking a little bit about ethics. Next week we'll be doing something on whatever. So the success of this whole program relied on, obviously, the person who was wandering around and walking around the room all of the time while the students were studying. They didn't know that, but they were doing. They were having good fun, by the way, and there was a lot of interaction. At the beginning, when I had different types or different cultures of students together, that it took some time for that to grow, but in the end, the students very, very much appreciated the input from the person who came from country X and another one who came from country Y. So overall, we had built a much better appreciation and awareness of different cultures and how different cultures think. And that's really important because engineering certainly is a globalized profession. And so as a graduate, you may well be working for a company, a multinational country, which says, I am going to take you to France. You need to work over there now with others, for example. And when the culture in that country is different to where they come from. So again, really, really important. So what I'm trying to say is this is one example. It is not the example, but it is one way in which you can, I'll say, embody a lot of those required learning outcomes that we hear from industry and the other reports from around the world into a program. So even though the students here learned a lot about, say, building and structures and whatever, it was done with a whole lot of other stuff inside it. And my contention was and is that the students learned not just about the technical bit that they needed to, but they also got a huge appreciation of the other bits which need to go through, like systems thinking, like being aware of different disciplines working together. And if this discipline does that, what can this one do and how do they work together? And also cross disciplines, although we weren't able to do that in this particular class because they were all engineering students. So I think just one more slide, I think it is. And so what I've probably said most of what the last slide says anyway, because it's just a conclusion of what we have done. So I'm saying, you know, I've used this in the collaborative learning spaces examples of, but you can use the same sort of process and thinking in the flipped classrooms and other approaches. So my contention is we can move to the next slide, the last slide, please. Yep, there we are. So if we're going to meet the future requirements of graduates, it's crucial that the engineering educators be creative. Creative in putting together, embedding these skills into the normal technical program, because the students still need to do the technical program. But if we can embed some of these other stuff into the technical program by using different examples, and that's also project-based, it's also problem-based, that's all embodied in there together. So I'm saying that if we are ever going to satisfy or work towards even the UN SDGs, engineering educators are going to need to be creative in getting that all into the curriculum and teaching it. And the bigger question that follows from that is, are our current educators skilled enough to do that, or do they need some more skilling? So that's where I'm up to. I'm very happy to take some questions if you wish. Thank you very much. Very much appreciate your time listening. I can't hear anything now. Sorry, I cannot hear.
Okay, so can you hear me now?
Yes, I can. Just. Can you a little bit closer to the microphone, maybe?
Yes. So I was saying thank you for your participation, and all of our audiences are really eager to learn more from you. But due to the time constraint, we can only pick out one question, and this has to do with the client empathy that you said earlier in your presentation. I would like to read out loud the question. Communication between the technical executor, in this case the engineers, and the results-focused clients can be tricky, not only in engineering but also in other fields like advertising. In your speech, you mentioned a term called customer empathy. Can you further elaborate on that, and how can we achieve customer empathy?
That's a very good question. I wish I knew the answer. let me just say, it's really important that graduates have the communication skills, which are not just I am speaking here, but I am also listening. Communication is largely about listening and largely about understanding what the other person is saying. It's also about persuasion and in terms of discussion about various options to a problem solution, for example. Um, Customer empathy is a really interesting one. If you're building a new road through a community and you need to resume some of the houses, it can be an engineer who goes out and talks to the community to say, this is what we're going to do, this is why we're going to do it, and I'm very sorry, but I'm going to have to use up some of your land or take up your front yard. So in that sense, the engineer in this particular case needs to be empathetic to the householder in that very particular case. So empathy is about listening, and it's about responding appropriately. I don't have a specific definition of what customer empathy is, but what it means is that engineers need to be aware of the customer, which might be the householder, of what their needs are, etc. It's not about, I'm going to build this road, there it is, done. And by the way, you've got to live with that. That's not the way it works. You need to be empathetic to in this particular case, the householder.
Thank you very much for your answer. Unfortunately, due to time constraint, we have to conclude this session with Professor Douglas right here. But before we move on to the next session, I would like to say thanks to Professor Douglas once again, and we wish you the best of health and even further progress in your career. Thank you very much for spending time with us, and we hope that we're going to have more opportunities to learn more from you. Thank you.
Thank you. It's been my pleasure.
Yes.